Hello everyone, welcome back to the channel. So today we are going to explain topic in operating system multi-level queue scheduling. Okay, so I will explain it in a simple way with examples, so you will understand it clearly. Okay, so what is multi-level queue scheduling? So in some systems, processes are divided into categories like system processes, interactive processes, batch jobs, student task, etc. Instead of keeping all processes in one queue, we maintain multiple queues, each for a different types of process. So each queue can have its own scheduling algorithm. See, so basically in many operating systems, we have different types of processes running at the same time. Okay, for example, like some processes are system processes, some are interactive user processes, and others like batch jobs. Okay, so now instead of putting all these processes in a single queue, the operating system separates them into multiple queues. Okay, so each queue handles a specific type of process. Okay, so see think of it like a highway with multiple lanes. Okay, so one lane for VIP cars, so these get the fastest route, and the other hand one lane for normal cars, regular speed. Okay, and the one lane for trucks, slower lane. Okay, so basically similarly in the operating system, each queue can have its own scheduling method. It's like one lane for VIP cars means system processes, one lane for regular cars, user processes, one for trucks, batch jobs. Okay. Now see how it works. Classification of process. Processes are permanently assigned to a queue based on their type. Example: foreground interactive means round robin, background batch first come first serve. Separate queues. Each queue is independent and has its own scheduling method. Queue scheduling. There is also a scheduling policy between the queues. Example: foreground queue has higher priority than background queue. Okay, see how it works. See. So basically first is process classification. Okay. Process classification. So every process is assigned permanently to a queue. For example, like interactive user process go to the foreground queue. Okay, and like batch jobs go to the background queue, and the system process go to the system queue. Okay, then separate queue. Okay, separate queues. So basically each queue works independently and may use a different scheduling algorithm. So basically the foreground queue might use round robin for fairness. Okay, the background queue might use first come first serve since like speed is less critical. Okay, then third is queue scheduling. So there is also scheduling policy between the queues. Example: foreground queue has a higher priority than background queue. See, not all queues are equal. Usually higher priority queues are served first. Okay, for instance, the system queue will always get CPU before the background queue. Okay, so like the CPU scheduler first chooses which queue to pick based on priority, then schedules a process inside that queue using its own algorithm. Okay, then see example: imagine two queues, foreground interactive scheduled by round robin, then background batch scheduled by FCFS. So basically if a foreground process is ready, it always run first. Background process run only when no background process are waiting. See, so basically suppose we have two queues: foreground queue for interactive task using like round robin, and background queue for batch task using FCFS. So Now if a foreground process becomes ready, it will always preempt the background process and get the CPU first. Okay, so background process only gets CPU when no foreground process are waiting. Okay, so this way interactive tasks remain responsive. Okay, remain responsive, and like batch tasks are proceed without affecting user experience. Okay, so here is the advantages. Separates different types of process, system user batch, efficient for priority based execution, flexible, each queue can use different scheduling techniques. Disadvantages: starvation problem, lower priority queues may never get CPU if higher priority ones are always full. Then rigid, once a process is assigned to a queue it cannot move to another. See, so why do we use multi-level queue scheduling? Cause separation of process types. First is separation of process types. So basically each type of process gets its own queue. Okay, then efficient prioritization, so critical process get higher priority. Then flexible scheduling, so each queue can use a different algorithm that suits its process type. Okay, and advantages of, like, first is starvation. So lower priority queues might never get CPU if higher priority queues are always full. Okay. Then rigid assignment. Like once a process is assigned to a queue, it usually cannot move to the another queue. Okay. Now see, think of it like an airport check-in counter. So VIPs have a separate fast counter, regular passengers have a normal queue, cargo shipments have a separate line. Airline operating system decides which counter to give more attention to. So that's a multi-level queue scheduling in simple words. See, so basically, see, think of an airport check-in counter. Okay, so VIP passengers have a dedicated fast counter. Okay, so regular passengers have the normal counter, and cargo shipments have their own counter. So basically, the airline decides which counter gets more attention based on priority, just like how the operating systems handles multiple queues. Okay, so multi-level queues scheduling divides processes into different queues based on type. So each queue has its own scheduling algorithm, and higher priority queues are served first. It's like it's efficient for real time and like interactive systems, but can cause starvation in lower priority queues. Okay, like see, mm, basically multi-level queues are like, see, imagine you are managing a busy airport. You have VIP passengers, regular passengers, and cargo shipments. Okay, treating everyone equally would be like chaotic, right? So, in the same way, an operating system handles different types of processes. Okay, so some need instant response, like your text editor or mouse input. We call them interactive processes. Others can wait a bit, like background file backup. So these are batch processes. Okay, and some are critical for system health, like memory management. So these are system processes. Okay, so basically now if we put all process in a single queue, a batch process might delay a critical system process, or an like interactive process could get stuck behind a heavy batch job. Okay, so this is where multi-level queue scheduling comes in. It's like creating dedicated lanes for different types of traffic. Okay, and Operating system divides process into a multiple queues. Okay, so basically each queues has a purpose. First one is system queue, highest priority. Then interactive queue, quick response. Then batch queue, low priority, like can can wait. Okay, so each queues can have its own scheduling algorithm. Okay, like interactive queue, round robin, cause fair time slices. Then batch queue, first come first serve, like simpler, no preemption needed. Okay, so uh, queue priority governs execution. So basically, CPU scheduler doesn't just pick a random process. It first looks at the highest priority non-empty queue. So only if that queue is empty, so the CPU considers the next lower priority queue. Think of it as a layered cake. Layered cake. Okay. So the top layer always gets attention first, and the bottom layers wait their turn. Okay. Suppose like we have Q1 system, two processes. Okay. Q2 interactive, three processes, and Q3 batch, two processes. So CPU scheduling it like CPU checks Q1. If any process is ready, it runs immediately. Then if Q1 is empty, then CPU checks Q2, running process in a round robin manner. Okay. If both Q1 and Q2 are empty, CPU moves to Q3. Okay. So basically a process in a lower priority queues can be starved if higher priority queues are always busy. So this is called starvation, and it's the main drawback of this system. Okay, so why use multi-level queues? Okay, so first is like separation of concerns. Each process type gets its own lane, and second one is better responsiveness. Like interactive processes don't wait behind heavy batch jobs. Then like flexible algorithms, so each queue can have a different scheduling strategies to suited for its like workload. So in real life systems, this design allows operating system designers to optimize performance for multiple types of workloads simultaneously. Okay, so so there are like two key challenges. First one is starvation of lower priority queues. If higher priority queues are continuously active, then low priority process may never get CPU. And second one is rigid process assignment. So basically typically a process is permanently assigned to a queue. It cannot move like dynamically based on behavior. Okay, so to solve this problem, some systems use multi-level feedback queues where processes can move between queues based on behavior. Okay, but like that's a topic for another day. Okay, now see, think of a hospital emergency room. Okay, critical patients means high priority queue, non-critical patients medium priority queue, routine checkups low priority queue. So doctors first attend critical patients only when there are no critical cases, so they move to non-critical and so on. So these ensures life-saving cases are never delay, exactly like multi-level queue scheduling in OS. Okay, so multi-level queue scheduling is about dividing and conquering process management. So it classifies processes, Okay, gives each a dedicated queue and schedules based on priority and queue specific algorithms. So basically it's highly efficient for real time and interactive systems, but like you must be aware of starvation. Okay, thank you.